right? Okay, let's see what topic we will talk about. And I'm going to talk about Weintek control solution with EtherCAT Protocol and CANopen Protocol and ModbusTCP with PU01 to do the motion control. And how many types of protocol can work with our motion function blocks? Okay, and then there are some new functions like CANopen on PU01 and Ethernet IP on iR-ETN. So let's moving on to the first part, Weintek control solution. And all the today's demo project you can download at this link. Yeah. Okay. Weintek control solution includes 3 parts. The first is controller, like CNTX series HMI or CNT control 01. Those can be a controller connect to the second part, coupler, over ModbusTCP, CANopen, and EtherCAT in order to control the IR module. And our IR module include digital module, analog, temperature, and motion control module. And as well as we provide Weintek codices library with motion control function block. And motion control function block can control the servo or stepper drive, stepper motor. And okay. And even directly control the motor to do point-to-point motion over EtherCAT or CANopen. Okay, let's see how to build the EtherCAT control solution with CNT control 01. Using CNT control 01, IR module can directly compact on the controller. To do the motion control, the simplest way using PU which compact on the CNT controller to sending a high-speed pulse signal to the servo drive in the past. And recently, we support EtherCAT Master. With the EtherCAT Master, we can directly control any brand of drive, servo or step drive, an inverter, encoder, and almost every third-party EtherCAT devices like iR-ETN. Depending on EtherCAT protocol, it makes our solution more various because we can properly choose a right solution to do motion control according to your application environment. And besides, CNT control 01 can be a controller, or CNTX series HMI also could be a controller. Using CNT HMI as a controller to do the motion control, not only EtherCAT, but also CANopen protocol as well. With CANopen and EtherCAT protocol, both can directly control the servo or stepper motor, inverter, encoder, and almost every third-party device which supports CANopen and EtherCAT protocol. You might wonder which protocol should I use in my application. Honestly, in my opinion, usually depending on your drive, support what kind of protocol and how many axes you will control. Commonly, over A axis, we use EtherCAT. Instead, on the A axis, use CANopen. And both protocol can control the motor. So on the CNTX series HMI, we offer more. We offer CANopen and EtherCAT Protocol for the user, right? And let's moving on to the EtherCAT Protocol. On the EtherCAT, controlling several model just string every device together on the bus. If we have digital or analog I/O requirements, we can add iR-ETN into the bus. And through Weintek library, we can directly control the servo motors. There is almost no limitation for adding access on the bus. We're able to add access as much as we want, even over 100 axes. And maybe you only knew the Weintek motion control function block can control the iR-PU01 under IR coupler. Actually, our function blocks are able to direct control all the drives over a network, including PU01 on the bus. So let's go to the practice to configure EtherCAT protocol on Weintek codices. So to configure EtherCAT protocol, the first step, we have to download the ESI file. And ESI file, which is description about the EtherCAT slave. So every device which support the EtherCAT protocol must have its own ESI file. Most of the ESI file we can download on the official website. And in our example, we're using Delta Servo Drive A2. So we're going to Delta official website and to the download center. Then we can find the ESI file. We can find the ESI file and download it. Then we open the codices. In the tool, we open the device repository to install its ESI file into the codices. Then we can add EtherCAT device, EtherCAT master, and we recommend you use EtherCAT master with the version 3.5.12, and then you can add servo drive A2 drive under the EtherCAT master. Okay, right? Then after adding device, we have to set process data on A2 servo drive. So on A2 servo drive, you can see the process data, and in the general, you click enable expert setting. Then we can set process data, and you may wonder how do I know which parameter should be adding in the process data? That's very simple. We can declare a axis variable instance and check mapping I and mapping Q. So variable instance in the Weintek library, in the base, this is variable instance. So we can see the mapping I and mapping Q. Mapping I and mapping I is this. And we just adding all the parameter into the process data. So input, that's all. It seems like all the parameter has been adding into the process data. And okay, so this is the example. We have done the process data. You can see all the parameter in the process data. And then after process data, we can set. We have to set a startup parameter. We have to set initial value in startup parameters level, and then you can do programming and mapping variable in the codices. So that's all the configuration. And remember, EtherCAT, on the EtherCAT master, you have to choose your MAC address. And MAC address and auto restart. Check auto restart. And automatic restart slave. And if you choose this, if you click automatic restart slave, if you shut down the controller and restart the controller, that will automatically connect to your slave. So that's all about the EtherCAT master configuration. So you just use our function block to do the motion control, right? Okay. Then moving to CANopen protocol. On CANopen protocol, you may think solution is very similar to EtherCAT. Yes, that's right. Because EtherCAT is like CANopen working on Ethernet, and both protocol can control a servo motor, inverter, encoder, and third-party devices. And through Weintek library, we can directly control a servo motor on CANopen. But CANopen cannot suffer too many motors because of the bandwidth is lower than EtherCAT. So we suggest not too much access on the CAN bus. So let's see how to configure CANopen protocol. We also can find EDS file on official website. Yeah, and our example is use Delta A2 server drive because A2 drive support EtherCAT and CANopen protocol, right? Okay, on the Delta's official website, you can see the EDS file. This is the datasheet of the A2 for CANopen protocol. So you just download it and install in the codices, right? Okay, and then we have to add CAN bus device, and in this step we have a faster way to add device. We can import PLC open XML file, which is packed in the Weintek codices package. And now we just add a CAN bus. Then on the canvas, we click project and import PLC open XML file. I find my PLC open file. Yeah, this is PLC open file, and we can see we predefine some server drive, stable drive, and our IR-PU01 on the PLC open XML. So we just choose the drive we have to use. So A2 is our use. So it's the faster way, and we have done predefine all the configuration in PLC open file. So in the PDO, we have done the PDO channel. So if you use PLC open XML file, you just do the programming and replace mapping variable, because the mapping variable here, and you just replace your replace into your declare variable, right? Axis, and replace all. Replace all. Yes. Okay, that's a faster way to add device and to do the configuration in codices. And you may not find the drive you use in the PLC open file, and you can tell us what kind of drive you use, and we will help you to create a model in PLC open file. And we've taken a video to configure CANopen drive, and you can download on the website. Yeah, if you forgot how to configure the CANopen protocol. Yeah, and this step will not only work on the CANopen, but also EtherCAT can work. So if you use EtherCAT, also can add a PLC open file under the EtherCAT master. So it's a simple way to do the configuration on EtherCAT and CANopen. And then, okay. And then you can do the programming and mapping, then logging test your programming, your motion control. All right? Then let's see ModbusTCP protocol. If you want to do the motion control over ModbusTCP, you have to use iR-ETN plus PU01. ModbusTCP protocol also can do the motion control to activate PU01 by motion function block, but no drive supports ModbusTCP protocol to directly control. So if we use ModbusTCP and also want to do some motion control, iR-ETN plus PU01 is the only way to do to control the motor. How to configure ETN plus PU? And ETN plus PU is the is different from EtherCAT and CANopen in configuration because ModbusTCP doesn't have ESI or EDS file. We have to do configuration by ourselves. All the Modbus address for motion control are manufacturer definition. This input and output address like process data in EtherCAT. And MNT control and this address have to set to value 2. And let's see how to configure ETN plus PU in practice. Yeah. ETN PU. And if you use ETN plus PU, when we add a device, we have to add Ethernet device. Ethernet device and ModbusTCP master and ModbusTCP slave. Then configure your IP address as your controller to the controller, and slave is the IP address of iR-ETN. Then the most important is the Modbus slave channel. This channel, according to the axis, which axis you wanna control, and we have to mapping to variable instance Modbus address. So input address from 40,000 to 40,015, and output address according to 40,500 and 40,515. So if we gonna control the axis 0, so in the ETN PU we add the channel with function code 23. Then this is input offset 4,000. Then length is the mapping i's length, about 12 word. And output start from 40,500. And length is 12 word. And okay, right? Okay, after we adding the channel, on the mapping side, we have to, on the mapping side, we should declare a axis variable. Then mapping the axis variable. Then choose the application and axis 0 and mapping I reg. Yeah, because in Modbus TCP protocol we send all the we send and receive all the mapping variable. So in IO mapping, we have done the IO mapping, and then we can do our programming and logging test. Oh no, one step. We have to do access PU object by our Weintek library. So when we have to access PU object, we have to use the library in the Weintek and SQLite and ETN PU folder under ETN PU folder. Then all the function block in the ETN PU folder to do access the PU object, access the PU object. So you just choose the PU object you want to access, then write the value and trigger. So this is the way to access PU object when you use ETN plus PU. Yeah, and when you have done the PU object, then you can use our motion function block to do the motion control on the iR-PU01. So that's all about our control solution. If you use controller which isn't a Weintek device, the control method to activate PU, you should refer to CIA 402. And PU object description, you have to refer to iR-PU01 user manual. And how to access PU object, you have to refer to iR-ETN user manual. That's because motion control function block only support Weintek device. So if you use IPC and use and control the PU01 over ModbusTCP, and you have to programming your own control method. Yeah. Okay. That's all the motion control solution. EtherCAT, CANopen, and ModbusTCP. And we summing up how many types of motion control our function block supports. The first, directly control the drive or activate PU01 to do the motion control over EtherCAT protocol. And the second, directly control the servo or stable drive or activate PU01 to do motion control over CANopen. And the last, activating PU01 to do the motion control over ModbusTCP. Our motion function blocks provide positioning and speed control. Recently, we will release torque control function block. So with our function block, you can do three types of control: positioning, speed, and torque control. So after our control solution, we're going to talk about some new functions of iR series. The first is CANmotion on iR-PU01. CANmotion is one of the synchronous motion. One axis is the master, and the other one is a slave. Slave follow the master moving to corresponding position according to the CAN table. So before running CANmotion, we have to create CAN table earlier. As you see, X represents master, and Y represents slave. On the CAN table, we can set some parameters to adjust the table, like engagement, which can set the start position of CANopen, or offset scaling the CAN table. And on PU module, we can separate path input and path output into two axes. Path input as a master and path output as a slave. Output will follow input moving to corresponding position according to CAN table. So then, and some parameters we have to aware when we use CANopen. Create a CAN table is essential. It's essential in the CANopen, and other parameters you can use the default value to test your CANopen. Then on the CANopen function block, you can do scaling and choose the CAN table. And we offer 3 tables for the usage. If you want to check how to set parameters to test the CAN table, you can download the CAN example project, and as we list in the beginning. Yeah. Okay. Then the last, another new function in Ethernet IP protocol, and this protocol can work on iR-ETN. With Ethernet IP protocol, iR-ETN can join the Ethernet IP control system. If you have a controller which supports Ethernet IP, it can control the IR module by Ethernet IP protocol. And the configuration of the Ethernet IP is very simple, because Ethernet IP like EtherCAT or CANopen has its own EDS file. So just import EDS file into controller, and we can control the IR module from other brand of PLC. So let's take a look at the importing EDS file. And if you're gonna to use these functions, you can refer to the iR-ETN Ethernet IP connection guide on our website. So on the website, we find a document about the Ethernet IP connection guide. Then in this document, we can find on the first step, teach you how to generate an EDS file and using Easy Remote I/O. So you just use Easy Remote I/O and scan the network. Then you can find a iR-ETN, and then on the file, you can export Ethernet IP EDS file to your PC. IP, yeah. Yeah, into your PC, and importing the EDS file into the PLC programming IDE. So, and then you can control the control our IR module from other brand of PLC. So and then on the in the document we offer codices and Rockwell and Panasonic how to import the EDS file with Ethernet IP. So and then on the Easy Remote I/O, we have another new function. Yeah, that is the broadcast. So with the broadcast, we can search the IP address on iR-ETN from the different networks. That's because if the IP address set to different network, and we still can scan. We still can find out our iR-ETN. So with these functions, we can find out all the iR-ETN in different network, right? Okay, and we can also modify IP address on different network. So that's very simple. Okay, and that's all. And today's class, if you have any question, you can leave the message on the message box, and if you wanna know how to do the motion control, you just beside the configuration, you just check our Weintek library, and you can find all the motion control function block, and this is all the function motion control you can do. Yeah. Okay. And if you have any question, you can leave the message.